This is the homework solution for page 229, numbers 10, 11, 18, and 22. Number 10 asks us to write an equation of the line that passes through the given point and has the given slope. What we have here is the given point and the given slope. To write the equation of the line, we want that in the slope-intercept form. To do that, we need a slope and an intercept. The first thing that we're going to do is find the y-intercept because we already have the slope. To find the y-intercept, we plug it into the slope-intercept form. So, y is plugged in to y for 1. M was your slope, which is 2. I plugged that in. And x was 3, and I plugged that in. Okay, so I make my substitution. I now simplify. 2 times 3 is 6. The left-hand side just becomes 1. Okay, I need to solve for b because I'm trying to find the y-intercept. To do that, I subtract 6 to both sides. Once I subtract 6 to both sides, b should be left over on my right-hand side. 1 subtract 6 is negative 5. So right here, I just solved for the y-intercept. Now, what I can do is I can write the equation in slope-intercept form because I have the two pieces. I finally have slope and I have the y-intercept. So I'm going to make that substitution. Okay. Y equals to 2x because 2 is the slope. That was what I was given. And the y-intercept is what I just realized, negative 5. So I plug that in here for b. So that is my answer. Y equals of the line. Next, I have 11. 11 as gives me the same directions. Write an equation of line that passes through the given point and that has the given slope. Okay, I have my points here and I have my slope. My first step is to always find the y-intercept because I already have the slope. To find the y-intercept, I make my substitution into slope-intercept form. 4 is plugged in here. Let me make that blue. Negative 1 is plugged in for my m because that is my slope. Negative 1 was my x value, so I also make that substitution. Once I make that substitution, I can now simplify. Negative 1 times negative 1 is a positive 1. Let me repeat that. Negative 1 times negative 1 is a positive 1. Okay? To get b alone, which is to solve for the y-intercept, I have to subtract 1. Okay? Because that is the inverse of 1. On my right-hand side, I get b. What's left over on my left-hand side, 4 subtract 1 is 3. Okay, that is my y-intercept. Now, I can write the equation in slope-intercept form because now I have both the slope and the y-intercept. So the slope here is negative 1, which is what I figured out, which was green. So let me make that green. And the y-intercept here is b, okay, which is positive b. So this should be a positive b, okay, because this is 3 and 3. Good? Alright, so that should be my equation. Y equals to negative 1x plus 3. Another way you can see this is normally we do not write the 1 in front of the variable. Sometimes you can just see it this way. But hopefully you notice that there is still a negative 1 out there, okay, in front of the x. Good? That is my equation in slope-intercept form. Next, I have numbers 18. Okay. Number 18 asks us to write an equation of the line that passes through each pair of the points. The difference between 18 and 11 and 10 is that notice how here I was given a point and a slope. Here I am given a pair of points. So I have one point and an other point. Okay. To do that, I need an slope and a y-intercept. So that's what I'm going to figure out first. Okay? To write it in slope-intercept form, I need two pieces. The slope, which is m, and the y-intercept. So, I need the slope and the y-intercept. Okay? Those are the two things that we have to figure out. So let's find the slope first. To find the slope, I write down the, I have to label my points. My first point is negative 5, comma 3, and my second point is 0, comma 7. Okay? I can label the points. x1 equals to negative 5 because this is x. y1 is 3. x2 is 0. And y2 is negative 7. There's negative 7 there. Okay? Now I can plug it in. y2 subtract y1 divided by x2 subtract x1. This is just the slope formula. Next, okay, y2 was negative 7, so let me just put a negative 7 here. Subtract 3, 0, subtract 3, okay, so 0, subtract x1. x1 is negative 5, okay, so let's see this. So y2 was negative 7. I have negative 7 here. X1, sorry, y1 is 3. 3 is right there. 0 is x2. And x1, negative 5. There you go. Okay, let's do my substitution here. What is negative 7 minus 3? Okay, another way you could think about this is just it's adding a negative. So negative 7 plus negative 3, this gets me negative 10. And on the bottom, minus a negative 5 is the same thing as adding 5, right? So that just becomes 5, okay? Because minus a minus just becomes an add. Good? So negative 10 divided by 2, I can simplify that. That can be simplified into 2 over 1. Okay? Right? Because you can divide the top and the bottom by 5. Or in other words, is you could pull out the GCF of 5. Okay? Now, once we have the slope, I'm going to make this green because that is the slope. So we found the first part, which is the slope. Okay, let's find the slope first. Next, I have to find the y-intercept because again, I'm going to write it in slope-intercept form. To find the y-intercept, I'm going to use this point 0, comma negative 7. I have noticed that this is already the y-intercept because if it's a 0 here and a negative 7, right, it's already in slope-intercept. It's already in y-intercept form. Okay, so I should notice that my y-intercept equals to negative 7. So this is my purple here. That is my B. So I should have my two pieces. Okay. My slope was negative 2 over 1. So it was negative 2 over 1. Okay. Plus negative 7. We don't write the plus negative 7. You would write this like this. Okay. You would just write this as minus 7, and the negative here you can, right, just leave it on top if you want, right? Okay, there you go. That is how the equation looks like in slope-intercept form. Okay, next one, we have 22. Let me just read the scenario to you first. Greg is driving a remote control car at a constant speed. He starts the timer when the car is 5 feet away. After 2 seconds, the car is 20 feet away, 35 feet away. Okay. The first question asks us to write a linear equation to find the distance of the car from Greg. Okay. So to write the linear equation, we always write it in slope-intercept form. Okay. Another way that you could look at the slope here is it's a rate, and the rate is referred to like the speed of something, like miles per hour. Okay, so I write it here. The rate here is 30 feet in 2 seconds. How did I get that? It says it right here. 2 seconds, the car is 30 feet away. You always want to look like a rate. Okay, you always want to look for a rate. 30 feet in 2 seconds. So that is my slope. M is 35 over 2 feet per second. Okay, that is your slope. Okay, this is my slope information here. Right? There's nothing else in this description, in the information, that gives me a rate, which is a distance, okay, like feet, in a certain time, which is seconds. After I found my rate, I want to find my y-intercept. Another way you want to think about the y-intercept is it's like a starting point, right? You know how you start at the y-intercept, right? Here, it's your starting point, or aka your starting distance, okay, which is going to be 5 feet. Here, y equals to mx plus b, right? Slope-intercept form, but I already made that substitution. So let me just write slope-intercept form. Then I can make the substitution here for you. Okay, negative, it's 35 over 2, which is the slope. make that green. Then the y-intercept is 5. That is my equation that describes, okay, the distance of the car for Greg. All right. Next, it asks us to estimate the distance the car has traveled after 10 seconds. Okay. What I have here is the slope-intercept form, and I think I wrote. Um, okay. But I need you to understand something about the slope-intercept form. Okay. These can be different units, but the way I think about y is your final distance. Okay. The final distance, which is y, is calculated from your rate, which is your slope, right? Which is the speed times time, okay? Which is your speed, um, okay? This is like a miles per hour, right? Times your x, which is going to be your time. Add to your starting distance, okay? This is an interpretation of the slope-intercept form, okay? So, what you can do here is that you can find the distance the car has traveled after 10 seconds. So, um, what was my time here? Okay. My time was 10 seconds. So, 10 seconds. Okay. What was my rate? My rate was 35 over 2, right? It was 30 feet in 2 seconds. So, let's put that in here. And what was my starting distance? My starting distance, right, looks like it is 5 feet away. Okay. That is my y-intercept. So I can put 5 here. Okay. There you go. Now you can calculate the final distance, which is 35 over 35. Okay. 35 divided by 2 times 10 plus 5. If you plug this into a calculator, you should have gotten 350 divided by 2, which is... Hold on, let me just write that out. 350... this should be in an equation format. Hold on. This should be 350 divided by 2, right, plus 5, right, because I just multiplied here, okay, which is going to be simplified into, let me see, 350, this is 175, I think. Hold on, let me see. Wait, hold on. It's one 350 divided by 2. So 350 divided by 2. 175, yeah. 175 plus 5, which is going to be equal to, okay, 180 feet. Hold on, something looks off. Let me see here. So my feet is 35 feet in 2 seconds, okay? So 35 feet in 2 seconds, okay? So let me just see if I can get a visual model of this. So let me just make a table out really quick, okay? Right, so this is my time, and this is going to be my distance, okay? I just want to double check my own work. So it starts at 5 feet, okay? It starts at 5 feet. So it starts at time, which is 0. I start at 5. Right? Every single 2 seconds, I go 35 feet. Okay? It's 35 feet away. Alright, so 2 seconds, it's 35. Okay? Okay, so from here, it goes up 30. So at 4, okay, from here to here, it's 30. So the next one should be 60... 65. Okay. At 6 seconds, this would be 65, 85. 8 seconds, it should be at 105. Okay, that is my distance. At 10 seconds, it is at 125. And at 12 seconds, it is 145. Okay. It says find the distance the car has traveled after 10 seconds. So 0 to 10 seconds should be 125. Haha, something's off here. Something is off here. This should have been 30. Okay, 30. Should be 300. Okay, this just becomes 150. Right? It becomes. It should still be 125. Hold on. In 10 seconds. Okay. The rate here is 35 feet in every single 2 seconds. Oh, wait. Does it say after 2 seconds the car is 35 feet away? Here. This is bad. Okay. So it goes up each time by 35. So here, 5 plus 35. Wait, hold on. But it says after 2 seconds the car is 30 feet away. So this would be the best correct answer. Okay. So the rate here is. So the rate here, let's see the rate. Hold on. The rate is 30 distance, which is 30 feet for every 2 seconds. So that is what I should do here. 30 seconds over 2. And the time is 10. That should be 50. So this should be 155. This doesn't make sense. Hold on. It's going up 30 each time. Okay. Alright, so I think there's an error based on the way the question is written. After 2 seconds, the car is 35 feet away. Right? So it's traveling 30 feet per second. 30 feet per second. 30 feet per second. Or you can think about this in terms of like 15 over 1. So it's going 15 seconds each. Oh, right here. Haha. There's the error. It's 30 each time. So this is 30, 60, 95, 9, 10, 11, 12. So this is 12. Then this becomes 155. Aha! Okay, I made the error. It's right here. Aha, it's right. I thought it's off. Right there. There you go. At 10 seconds, it should be at 155. Yes! Math makes sense. There you go. Okay? So, it's 30 it's 30 feet every single 2 seconds, okay? Because it starts here at 0.5. In 2 seconds, it's 35. So it's going each time from here to here, it's going up by 30 right here. 30 feet per every single 2 seconds. So this is feet. Okay, and this is 2 seconds. Okay, there you go. Alright? There you go. Got it. Alright? There you go. That is your homework solution for 10, 11, 18, and 22. 22 is a little bit hard because you gotta, I had a formula, but I also want to double check my work by making a table. I want to make sure that it fits, okay? Alright, there you go.